All right, welcome everybody to the first ever phiVis Philosophy of Vision Science workshop. My name is Kevin Landy, and I'm an organizer of this event along with Chaz Firestone. I'm an assistant professor of philosophy at York University and a member of the Center for Vision Research here. And my work is in the philosophy of vision science. In this area, philosophers try to answer basic questions about the nature of perception, the mind, and knowledge, both on the basis of the latest results from vision science, but also by carefully teasing out what are some of the core concepts, frameworks, and commitments that make the productive science of vision possible in the first place. In doing so, we consume a broad array of experimental research, but we also try to be familiar with the process, the people, and the institutions of that scientific work. So when philosophers and vision scientists get together, it's clear that philosophers have a lot to benefit from. But in turn, and I really don't mean to be too presumptuous here, I understand it that from these sort of conversations, experimentalists sometimes gather new context for their work, new insights into their research programs, and maybe inspirations for future projects. That's not to say that communication across fields isn't always smooth. It isn't. We're often driven by slightly different questions, concepts, and priorities. So the goal of phiVis is to expand the conversation and to give more of a chance to understand where we're all coming from. And I have to say, I've been really impressed and inspired even by how open many vision scientists have been on the occasions that they spot some interloping philosopher hanging out in the corner of the lab or the conference room. So I now want to turn things over to one of those vision scientists, Chaz Firestone.
Thank you, Kevin. My name is Chaz Firestone, and I'm an assistant professor of psychological and brain sciences at Johns Hopkins. But I also teach and advise students in our philosophy department. And in fact, several members of our lab at Hopkins have graduate degrees in philosophy and work at the intersections of these two fields. And having one foot in the door of philosophy has really helped me appreciate the care and attention to detail that philosophers bring to their engagement with the experimental literature. Philosophers basically cultivate deep, careful thinking as like their intellectual superpower in ways that I know our field can benefit from, if only because I know how much our own lab's work has benefited from it. And that's true not only as researchers designing and interpreting experiments, but also just as people interested in foundational questions about perception. Now, at the same time, it's true that our two fields differ in many ways. And like Kevin said, it's often the case that we don't have quite the same language or background to bring to these conversations. So part of our goal with this workshop is not only to actually engage in these exchanges, but also to learn how to have them better so that we can arrive at the most fruitful, most interesting, and most productive, and also just most fun ways to talk to each other. And to do this, it was important that we bring this exchange to the center of the vision science universe, which of course is VSS. I think this is my 12th time at this conference, and many of you will have been here even longer than that. And so what you all know is that there's a real sense in which VSS is the field of vision science. In fact, by hosting our first event as a satellite meeting of VSS, I think this virtual room that we're in right now together may have already set the record for the largest joint gathering of philosophers and psychologists interested in visual perception. So let's get to it. I'm going to turn things back over to Kevin, who will tell you about our schedule.
Thanks, Chaz. So we're going to have 3 20-minute talks from philosophers of vision, and each talk is going to be followed by a brief discussion from a vision scientist. All 6 of our participants are leaders in their fields, and we are extremely super grateful that they've agreed to join us today. After each round of comments, there's going to be a brief Q&A period. So you can message your questions at any point to the chair of the session. We have 2 amazing chairs today. We have Karen Schloss from the University of Wisconsin-Madison, who's going to chair the first 2 sessions. And then we have Jorge Morales from Johns Hopkins, who will soon to be of Northeastern, who will be chairing the final talk and also an open general discussion in which we welcome questions to the whole panel of speakers and commenters. And while the official schedule says that we end at 5:30, our panels agreed to stick around until 6 so we can have a fuller discussion, and we hope that many of you will stick around too. I'm now going to turn things over to Karen for our first talk.
Hello, I'm excited to introduce our first speaker, Ned Block. who's a professor of philosophy, psychology, and neurosciences at NYU. His work has played a central role in both philosophical and experimental research on the nature of consciousness. He is currently writing a book on the distinction between perception and cognition, titled The Border Between Seeing and Thinking. The title of his talk is Perception is Not Non-Conceptual. Sorry, Perception is Non-Conceptual. This is not the audience to accidentally add a double negative, sorry. You can go ahead and share your screen.
I'm sorry. Now, can you hear me? Yeah, good. Okay, so let me just reset my timer here. Okay, so philosophers have been arguing about whether perception is conceptual or non-conceptual for quite a while, but I only know of one or two cases where anybody has mentioned any actual experiments that bear on it. So what I'm going to do is give some arguments that a perception is non-conceptual, and using experiments both from development and from adult psychology and neuroscience. So I'm going to talk about color. Now, color is a low-level perceptual feature, and so the argument I'm going to give isn't going to apply very well to high-level perception. I think similar points can be made about high-level perception, but I'm not going to get to that. Okay, so I'm going to start with the claim that between 6 and 11 months old, babies have color perception without any color concepts. So the color concepts cannot be involved in those perceptual states because they don't have the color concepts. So here I have a picture of a baby who looks to be in this age range, and babies before and after it. So I'm going to make use of some results involving categorical perception of color. So as everybody knows, the rainbow is a result of a continuous band of frequencies, but we see it as stripy. That's categorical perception. Its behavioral realization is that people are faster and more accurate if they're discriminating between two equally separate wavelengths across a category boundary than within a category boundary. Now, there are a number of ways to test behaviorally whether people have categorical perception. And I'm going to be using the work of Anna Franklin, who's done a lot of work on baby color perception. So one method she uses is an extremely simple method, which is you have a screen of a uniform color and then a disk of a different color. And if the baby sees it as a different color, the baby will just move the baby's eyes to that different color. And adults do this too, by the way, so you can use the same technique with adults. Now, and this allows you to tell whether they see it as different colors, so how good their color vision is. But interestingly, it also tells you about their color categories, because they move their eyes more quickly if the background and the disk are from different color categories, allowing us to sort of map their color categories. Another technique involves habituation. This is a habituation setup. You have the baby on a parent's lap and a screen. The baby is hearing certain things. The adult can't hear them. And what you are looking for is habituation. So if you have the same color on the left and the right repeated, the baby will stop looking at the screen and look at its feet instead, or something. Then if you have a novel color on one side, the baby will tend to look at that novel color if it sees it as a novel color. So you can gauge the extent to which the baby sees it as a different color category from the one that's been going on by how much time the baby spends looking at it. Using this technique, the previous one, and verified using some other techniques. What Anna Franklin has shown is that babies have 5 color categories. So the way to read this diagram is that the squares that are linked by lines are the same category. If there's a gap, then that's a different category. And there are 5 categories, which most of which are actually correspond fairly well to something we can name in English. So here is a little diagram of the infant color categories and how they correspond. These circles are boundaries in the infant's color category system. And the stars are indicators of a particular language group corresponding roughly with the baby color category. So in English, our breaks correspond to 3 of those gaps, but then there are some other language groups that don't correspond as well as ours do. So the argument is that between 6 and 11 months, they have color perception without color concepts. Now, of course, I'm gauging whether they have color concepts by whether they show the abilities diagnostic of color conception, and I'll explain how we can test that. I should say that babies of this age do have the abilities that are at least somewhat indicative of concepts of shape, size, and kind. So again, here's the slide that I showed before. So here's an experiment that I like because it's longitudinal. So this is a case of where you have a narrow barrier, just the size of a ball that's rolling across the stage. You roll a green ball behind the barrier, and then a red ball emerges. And the question is the baby looking at this surprised? So what's found, this is Wilcox, 1999, found that if a ball turns into a box, they are surprised, but not if a red ball turns into a green ball. By 7.5 months, they can use shape and kind, but still not color. It isn't until 11.5 months that they can use color as well. So that seems to be when the ability to use color in reasoning seems to come in somewhere between 11, 12 months, roughly that area. So I think one thing to think here about this is that they're simply not noticing the color. Now, another possibility is that they have a concept of color as a temporary feature or a non-abiding feature of an object. But we can show that's wrong by this experiment by Jean-Remy Hochmann, where he only looked at 12-month-olds. And here's what he did. He had a screen that the baby was looking at. And depending on what's shown on the screen, a very interesting phenomenon occurs next. And that phenomenon, say, might be a jumping, squealing frog on the left. And the question is, could they learn the rule, same shape, jumping, screaming frog on the frog on the left, or same color? And what he found was that they could learn the same shape, but they could not learn the same color. The results were just starting to trend in the direction of same color by 12 months old. Another paradigm, so that shows that it can't be that they have a concept of color as a non-abiding thing. This doesn't depend on whether the colors are temporary or not. It's just whether the same color now predicts something. So I think that this rules out an interpretation of the previous one. Here's another one. You get a red thing moving out from a blue thing moving out from one side, a red thing moving out from the other side, and then the screen goes down. Under 12 months, they don't expect 2 things, but much earlier, they use shape and kind information, maybe 6 months earlier. Here's another type of experiment. This is Tremblay, Leslie, and Hall. So if you have an object going out from a screen and coming back, and then another object a different object coming out from the screen and going back. Babies are surprised if those two categories are not represented in what's below, but not for a change in color. And these are some of many experiments that probe the question of whether they have conceptual abilities used to reason or think about color. And my argument is of the suspicious form of absence of evidence showing that they don't have the concepts. So look, it's vulnerable to somebody finding something that they can do using reasoning, but at least so far I haven't found anything in the developmental literature suggesting they can reason with color before 11 months. A further item of evidence for this is that children don't learn the 4 basic color words until, on the average, 3 years, 3 months old, more than 2 years later. And a nice experiment by Mabel Rice took a group of 2 to 3-year-olds who knew no color words, taught them the difference between red and green. For most of these children, learning that difference took 1,000 trials or more. So it's not just that they don't reason with colors, they're extremely resistant to being taught colors. I should say that children are getting more sophisticated with color reasoning, or rather sophisticated, or rather they get it earlier. At the turn of the century, IQ tests in Europe suggest that children didn't get the 4 basic color words until they were 7 years old. In, I believe, 1980, it was the work was done showing 3 years, 3 months, and some work by Dave Barner suggests that the proliferation of colored plastic objects in the environment has moved that age even earlier. Interestingly, there's a lot of historical comments on this. So here's Charles Darwin saying, I attended carefully to the mental development of my young children, and with 2 or 3, as I believe 3 of them, soon after they had come to the age when they knew the names of all common objects, I was startled by observing that they seemed quite incapable of affixing the right names to the colors in colored engravings. Note the colored engravings, they didn't have all that plastic. Although I tried repeatedly to teach them, I distinctly remember declaring that they were colorblind. And a term that was coined about this phenomenon, Farben-Dummheit, color stupidity. So just to summarize, infants can see colors at nearly adult levels at 4 to 6 months, and they do perceptual categorization of them. They can use shape and size and kind information in reasoning about colors, or something that looks at least a little bit like reasoning about colors, 6 months before they can use color information. 2 years later, most children don't know the 4 basic color words, and they're quite resistant. Substantial reasoning with color seems to happen at the same time as learning color words. That is, reasoning more substantial than these expectations. So 6 to 11-month-olds look like they have color perception without color concepts. Now, there is a problem in this reasoning, which is maybe the 6 to 11-month-old color perception is non-conceptual, but maybe the adult's perception of color is conceptual. And this is supported by the finding that, so this is within category initiation time and between category. And as you can see, in infants, this is the left visual field, this is the right visual field. In infants, this is a left visual field, right hemisphere phenomenon. They don't show it in the left hemisphere. Adults, it's both, in fact, slightly greater in the left hemisphere. And that, might be taken to suggest that maybe adults have some kind of a conceptual overlay of color perception. So this leads to the question of whether adults have both non-conceptual color perception, and maybe conceptual color perception in the left hemisphere. So a recent study speaking to this possibility suggests strongly that that's not the case. This is Hedjonides. I just saw this actually in Neuroimage. At least I think it came out just last week. Hasn't got page numbers yet. So I'm only going to go very briefly into this because I'm limited in time. But here's what they did. They took 48 colors around a slice of the color circle. They put them in Gabor patches randomly differently. And subjects were asked to pay attention to both the color and the orientation. And then in the color case, to make sure that they were paying attention to the color, 700 milliseconds later, there could be a circle, and they had to move a cursor to the exact color that they saw on the left, or if it was on the right, on the right. So this made sure they attended to both colors. And the result is this, that the stimulus, sorry, I forgot to mention, this is a decoding experiment. So the idea of this is to look throughout the whole brain and to determine where you get the best decoding of color information, of what color the subject is seeing. So, and what they found is by far the best decoding, in fact, really the only really good decoding, is contralateral in the back of the head. And it's the same for orientation, almost the same results for orientation. And then you see them expressed here in a somewhat different way. And color decoding was as good or better than orientation decoding. So there are three important things about this. They're in the back of the head, not in language areas, not in frontal conceptual areas. They're contralateral, which again suggests visual, sensory, the sensory nature of it, and they're fast too. Here's the let me read this first. Here's what the authors say. Activity in posterior electrodes contralateral to the decoded stimulus were the primary contributors to the decoding of both features, that is color and orientation, suggesting that visual sensory processing was the main source of decodable signals, ruling out alternative explanations of color decoding such as verbal labeling. And here's the speed. This was 150 to 350 milliseconds was the where they got by far the best results. So I think that suggests probably we don't have conceptual color perception in adults. Some other items of information that I think are relevant. So in one experiment, the time it takes to move your eyes to a target of a different color category is the same for both hemispheres, about 350 milliseconds. No advantage for the left hemisphere, as would be expected for verbal concepts. And if there were conceptual color processing, then that would be presumably take a bit more time. I emphasize that these experiments don't speak explicitly to consciousness of color. This is really about color perception independently of whether it's conscious or unconscious. So here's my summary, and I'm finished before 20 minutes, almost finished anyway, is that 6 to 11 month old infants have color perception without color concepts. There's some evidence that adult color perception does not involve an extra conceptual representation, and I raise the same caution that I raised at the beginning, which is this is all low-level perception, and it doesn't speak to high-level perception. That would be the topic of another talk. And thank you.
Thank you so much for that interesting talk. So now we're going to move on to our comment period where Anya Horobler will provide a comment. So Anya, you can go ahead and share your screen. Anya is a professor of visual neuroscience at Newcastle University. Her research has made major contributions on our understanding of color vision and color constancy. So Anya, you can go ahead and get started.
Great. Thank you very much, Karen, and thank you very much, Ned. I'm not a philosopher, so I fully expect to be shot down, because one thing I've found, sorry, I'm just trying to find my, there we go, video so you can see me. One thing I found in discussing anything with philosophers is that they basically always win. So, but I'm going to make an attempt nonetheless to respond to Ned. And I'll start by recapping his argument. And this is apologies, because I did this recap before I heard his talk, but after I read his wonderful chapter from his upcoming book. So I think his argument is that perception is fundamentally different from cognition, because not all perception is conceptual. And in particular, color can be perceived without having a concept of color by infants. And so to support that statement, he argues that infants perceive color without having the concept of color. And furthermore, adults do not have conceptual color perception. And this argument is largely based on the very recent Hadjanides paper, which shows that there's a lack of categorization effects in the neural activity underpinning color discrimination. So I'm going to just take up a few points here and just be try to present some, well, not necessarily counter arguments, but ask some questions just to probe a little bit. And these questions are, is that really color perception by infants? And do adults not have conceptual color perception? And I can ask that question because I can say, if we would be surprised when the ball rolling behind a screen changed color, would we not call that conceptual color perception? But also come back to another point related to whether adults have conceptual color perception. But I think this all leads us to the question of what is color anyway? And the really interesting thing is, why is color generally so different between children and adults? I think we can get a handle on what color is by looking at the difference between them. But then the other thing I think I should say is, why should we care? Does it matter whether color perception is conceptual or non-conceptual, especially to a vision scientist? And I think it really does matter a lot to vision researchers, where the distinction between a perceptual effect and a cognitive effect is highly pertinent, and we talk about it all the time. And I think the Hadjanides paper makes this really clear. I mean, their stated aim is to demonstrate that neural activity corresponding to the decoding of color is purely visual. And they put visual in quotation marks. So they want to show that you can decode color in a way not tainted by a cognitive judgment or linguistic classification. And they specifically look at posterior areas for that reason, because they think that is where sensory or purely visual processing takes place. And the other thing to say is, it's a really pertinent distinction for the Vision Sciences Society, because we can say, I mean, at what point then would this conference become the Cognitive Sciences Society, if we had to make the distinction? Or ECVP would be the ECV not C conference, the European Conference of Visual Not Cognition. I mean, we really do have to get a handle on that. And I think the other reason is that it's important to note that unless you believe that perception is non-conceptual, you can't then argue for cognitive penetration of perception or top-down effects on perception. And again, those are really important effects that we're, often as vision scientists very concerned with. So let's take, for example, memory color. So there's a notion that we form memory colors in our minds for familiar objects with diagnostic colors. And the classic example is a banana. So memory colors what enable us to determine there's something wrong with this cluster of bananas or this image of a strawberry. But the holy grail, or one holy grail of color research, has been to find memory color effects in everyday perception. As you can ask, does memory color influence the immediate colors that we perceive? We know memory color exists. The short answer is probably yes, but the effects are either very subtle or really inexplicable. So in the now famous study by Torsten Hansen, Marie Okkonen, and Carl Gegenfertner, it was shown that people would adjust a banana shape to look gray by adding more blue than they would if they were adjusting a simple disk to look gray. And the argument is that because you know this is a banana, your immediate perception is tinged with yellow and you have to cancel it by adding blue in order to make gray. But this effect is very subtle. These are actually really small effects here. And it's quite difficult to replicate this effect with objects whose colors are along the red-green dimension, for example, strawberries. So it might be more to do with the inherent variability of matching, making matches along a blue-yellow dimension. And that in turn might be linked to the inherent variability of the illumination spectrum, the daylight, in daylight illumination. And there are other effects attributed to memory colors that are much less easily explained away. They're very powerful. The paradoxical memory color effect reported by Hassan-Tash, Lever-Sousa, and Conway shows really quite vividly that faces turn green when they're seen under impoverished lighting. And this is attributed to our memory color for faces specifically, because it doesn't work for skin color on other parts of the body. We can ask the question, okay, did Edvard Munch live under sodium light? This is his painting called Jealousy, and his faces are often green in the way Edvard Munch paints them. But what's he meaning with that color green? I think that brings us to this question of what is color? And I mean, there's such a long history of color in philosophy, and in particularly in the philosophy of mind. And forgive me, all you real philosophers, but let's just characterize one of the key debates as whether color is out there, a physical thing in the world, a physical property of objects, which is a view that Aristotle believed that color belonged to the object itself and that sight revealed the world to be what it is. And I think this view is actually still really firmly embedded in the collective psyche. And Masvita Chiramutta calls this the intrinsic intuition, that we believe that objects are intrinsically colored. And I think the existence of this intrinsic intuition is what caused people to be so upset by the dress, because if color is intrinsically part of an object, if somebody tells you, no, it's not black and blue, it's actually white and gold, you feel like they're actually really questioning whether you've got a proper grasp of reality. And there's a minority of philosophers who claim that color is in fact surface reflectance as a physical property of objects. These are the
about 2 minutes, Anya.
How much?
About 2 minutes.
2 minutes left. Okay, right. Okay. And the other view is of subjectivists, that color is actually in here in the brain. And there's a more nuanced view around, which is that color is actually an interaction between the perceiver and the environment. And what we're getting at now is where and how in here is does color take place? And I'm deliberately saying not color perception or color conception. And we have lovely results from Beville Conway's lab and Rosa Lever-Sousa demonstrating that actually color is in anterior infratemporal cortex of the brain. And here color might actually tell us more about changing material or behavioral properties and therefore guiding behavior. But just to quickly go back to the other questions I raised. So do infants perceive color? I said that the argument is that perception is non-conceptual on the basis that infants lack concepts of color, but they can see color. But I just want to say that the evidence perhaps for perceptual categorization might not be that strong. It might simply reflect the neural structure of low-level spectral encoding and the notion that infant color categories that you see are actually just predicted by the fault lines in the early encoding of the spectral stimuli. And likewise, computationally, you can show that if you include cone opponent models in encoding color, you can actually predict focal colors. So I'm going quickly through this. And also to say similarly, I think the Hadjanides paper does demonstrate that there's neural activity in posterior visual cortex, which encodes the spectral qualities of the light stimuli, but so there is in the retina as well, because you could read off colors by what's encoded in the retina. And would you claim that that means we don't have conceptual color perception? I'm not sure. So lastly, I just want to say that infants I think there is a infants don't conceive of color, and they don't conceive of it as a stable, permanent property of objects, and neither should they, because the only reason why we're able to do that is because we have color constancy, which enables us to see these lemons as yellow, whether they're under blue light or yellow light, despite the fact that the light they send to the eyes is very different under the two conditions. And I'm just sort of cutting to the chase here to say that if after reading Ned's chapter and thinking this all through, I would sort of say that my view, based on all of this, is color is a mental construct, a property ascribed to material surface and objects that visual processing extracts from spectral variations in the light signal, and that color constancy ensures that dynamic changes in this property reflect real changes in the objects, and these are changes that we care about, such as rightness, health, or decay, rather than changes due to environmental illumination conditions. Skip this. So infants don't have color constancy. They don't have conceptual color perception either. Color perception develops into color conception. And I'd say that color constancy demonstrates that adults have conceptual color perception, or more contentiously, that adults have color conception, and that anything that happens before that, as in, for example, primary visual cortex, is perception, but it's not of color per se. So I'll stop there. Thanks, Karen.
Thanks so much, Anya, for that super interesting comment. We've been getting so many interesting questions in the chat, so I'm going to start calling on people. I don't think we're going to be able to get through all of them, but it's so exciting to see how lively the questions have been. Okay, so Sam Clark, do you want to get us started? You can go ahead and unmute yourself and ask your question.
Oh, now I'm unmuted. Sorry, it was coming up with a sign saying that I wasn't allowed to. Okay, so I guess maybe my question isn't particularly deep. I guess I just wondered kind of how you're thinking about concepts, Ned. So it seems like you're understanding, the owning of a concept as being a kind of ability. So infants don't have color concepts because they can't use color concepts in the right kind of reasoning. Is that right? I guess it seems to me that
I think reasoning might be too loaded a word. Forming expectations may not be exactly reasoning, but it's something in the direction of reasoning.
Yeah. Okay. So would it be enough that I guess I'm just kind of thinking about how you'd want to push back. So there's kind of like various ways of fleshing out that kind of concept as use or ability kind of hypothesis. So one thing would be, to show that they're systematically incapable of using those representations in a certain kind of reasoning. In order to show that, I guess you'd want to see arguments against the kinds of explanations that might be given by someone who wants to posit kind of continuity between the infant abilities and later developing adult abilities. It seems like it's a kind of discontinuity that's really an issue then. That seems like the crux of the matter, not just that you get these dissociations all over the place, like precocious infant abilities, and then children are slow on the uptake.
Look, it would be good to map out longitudinally exactly how the concept of color develops. So I don't know how much data there is really that goes into just where that discontinuity is and what its causes are. But I agree that would be still more and better evidence. I don't think it would change anything, though. There is a wide range of different kinds of experiments where children just fail to exhibit the conceptual, the kind of conceptual abilities. I should say that I wouldn't go so, maybe I should be more careful than saying they can't. It's not so much that I'm saying they can't, is that they don't. And that there's a reason why they don't. So you might find some kind of interventions that would produce color concepts earlier.
All right, so thank you for that discussion. We are actually gonna have to move on to our next speaker, and we can come back to all of the interesting questions in the discussion at the very end. So please hold your rest of your questions, and let's thank Ned and Anya for their talks. All right, so Jesse, you can go ahead and start sharing your screen. Our next speaker is Jessie Munton, a lecturer in philosophy at the University of Cambridge. Her core areas of research are philosophy of mind, epistemology, and philosophy of psychology. And the title of her talk is Seeing How Things Could Be. You can go ahead.
Thanks very much. It's fantastic to be a part of this and to be talking to a few more people that attended my last birthday party. The question I really want to organize my contribution around, slightly at odds with the title I gave, is really the question of what we can see, because I think that's perhaps the most fundamental question in our understanding of visual perception. And it's a question that I think we can only really make progress on when psychologists and philosophers work together. And so my aim is to pursue this question of whether we can see invisible objects in particular, but to use that as a way of highlighting where I see the joints between philosophy and psychology as being in this area of inquiry. So when I was reflecting on this question of what we can see, I found it remarkably hard to find things which it's entirely uncontroversial that we can see. So a few things are uncontroversial, but we can see shape, but we can see color. But the list of things which it's controversial whether or not we can see them is much, much longer. So whether or not object perception is really a kind of perception or a kind of cognition is controversial. Whether we see movement or if that's something we just construct later on at a post-perceptual stage of processing. Whether we can see relations like causation or chasing is controversial, or historical properties like shape, history, or higher level properties as philosophers might call them, like the property of not just being green or particular shape, but of being an elm tree. And I think it's worth reflecting for a moment on why we care so much about this question of what we can see. And I think there are three main reasons. One is that it goes to the heart of the question of what visual perception is. It's this fundamental way in which we relate to the world, but what are its limits? What's the nature of the connection to our environment which it offers us? Secondly, it's a question that is at the heart of the border wars between perception and cognition, as we saw in Ned's talk. And we're interested, I think, when we ask what we can see, in understanding where perception ends and cognition begins, in understanding what the nature of that boundary is and what implications that has for the organization of the mind more broadly. And perhaps more for philosophers, it has significant epistemic implications, what we can see, because it will determine what kinds of things we can learn from visual experience. And philosophers have sometimes wanted to give perceptual experience this kind of foundational epistemic role that on which we can build an edifice of further inferential knowledge. But if that's the case, it would be nice to know what kinds of beliefs can enjoy that really foundational sort of justification and which ones can't. So I want to pursue this question of what we can see in the context of two more specific inquiries. So I'm going to spend most of my time talking about the question of whether we can see invisible objects. And if there's time at the end, I want to say something very briefly about whether we can see ways things could be, but are not currently, what philosophers might call modal properties, but I'm going to avoid that phrase because it sows confusion between philosophers and psychologists. And I'm interested in these two questions because there's a very natural answer to both of them, which is no, we obviously can't see these things. And I think that natural answer is grounded in a particular way of thinking about visual perception that's tied to an understanding of the kind of mechanisms which underwrite it. So a natural thought goes, look, here's how visual perception works. It's dependent on light waves reflected from objects being detected by a light-sensitive surface, the retina, and then being processed cortically in various ways. Now, invisible objects can't reflect light in the way they would need to in order to be detected by this system. Equally, non-actual properties can't reflect light because they're not part of the actual world. So of course we can't see them either. I want to argue that, in fact, we should answer yes to both of these questions. And in giving you an argument for that, I hope to loosen the hold of that kind of way of thinking about visual perception. But firstly, let me say what I mean by invisible objects. So I mean that an object is invisible when it is incapable of reflecting light in a manner that could be detected by a light-sensitive surface, such as the retina, or when such information cannot be transmitted to the cortical visual system. So the two cases I'm kind of gunning for there, to put it more simply, are objects are invisible when they're occluded, when there's something in the way of you seeing them, and objects are invisible when you've got your eyes shut, so you're not able to process that information in the relevant ways. So to make it more tractable, I want to focus in particular on cases of transitory occlusion. So when you have an object that approaches an occluder, it passes behind the occluder and emerges on the other side. So my question is, what do you see at time t3 when the object is behind the occluder? Can you see the object when it's behind the occluder? What do we need in order to answer this question? I think there are two key ingredients. We need some criterion on what it takes to see something, and then we need a way of applying that to the case in point. So I'm going to start by giving you a criterion of what it takes to see something. And I should emphasize that this is meant to be as uncontroversial a criterion as I can find. It's quite loose. It's supposed to be a precisification of a kind of pre-theoretical notion of seeing that we might agree on. So according to this criterion, a subject S sees an object O. I don't know why philosophers like to do this S and O thing, when they actively maintain a reasonably accurate visual representation of O that is causally related to O in the appropriate way. And I've used my colors here to try and indicate that there are three key elements to this definition. Firstly, you have to be actively maintaining a visual representation. And for time constraints, that's really the only part of this I'm going to focus on in any depth. It needs to be reasonably accurate. So if it's wildly inaccurate, we wouldn't say that that was you seeing the object. And it needs to be causally related to O in the appropriate way. It can't be accidental. There has to be a link to the object in question. So how do we apply this to the case in point? Well, what I want to suggest is that before we can even get to applying it, we need to answer a prior question. So if we focus on T3, this is what is visible to you at T3, the occluder. Can you see the object at T3? So what we want to know is, are you maintaining a reasonably accurate visual representation of the object at this time? And if we treat T3 in isolation, the answer seems quite straightforward. It seems like, no, you obviously can't see the object. But the prior question we need to answer is that a legitimate move? Can we treat T3 in isolation? Or do we have to consider it as embedded in a longer period of visual experience? And should that inform our understanding of what you can be said to see at T3? And so the prior question we face is visual experience temporally extended, and in what way? Now, you might be thinking, well, obviously my visual experience is temporally extended. I was having a visual experience a moment ago. It's still carrying on. There you go. You've got some temporal extension. So what we're really asking is whether it's temporally extended at a fundamental level. So let me say a bit more about what I mean here. So we can distinguish between what I'm going to call sort of atomism, a view according to which at a fundamental level, visual perceptual experience is composed of units with no significant temporal duration, which then gets stuck together in some kind of a string that does have some kind of temporal extension of significance. Now, if atomism holds, then facts about an extended period of experience depend on facts about the momentary units which compose it. And I want to contrast that with dynamism, the view according to which the most basic units of visual experience are themselves temporally extended. And dynamism brings with it a kind of holism, according to which facts about a moment of experience are derivative from facts about the longer experience of which it is a part. And the reason why I've included this picture of the Van Hallens here is because you could think of this holism as a little bit like facts about familial relations. So there's no fact of the matter about whether you're a big brother or a mother or an aunt. If we think of you entirely in isolation, we have to consider the family as a whole, and then facts about your familial relations are derivative from facts about the family as a whole. So what's crucially at stake here is what the relationship is between what you see at a moment in time and what you see during the surrounding moments in time. Now, there's a lot to be said about the debate between atomism and dynamism in its own right. What I want to do is just assume dynamism and then ask what follows from that. So if we return to our case, what does dynamism change? Let's take our criterion of seeing in a moment. But the key thing that's going to change is that facts about experience at a moment in time are derivative from facts about the longer period of experience of which that moment forms a part. And so what this means is that we cannot treat T3 in isolation if we presuppose dynamism. Instead, we have to consider this longer period of experience. For the sake of argument, we can say it runs from T1 to T5, and then ask how we attribute content to T3 on the basis of that. Now, when you see an object move behind an occluder, it's very natural to describe it as just that you see the object pass behind the occluder and come out the other side. It isn't so natural to say that you saw the object come closer to the occluder, get progressively smaller on one side, and then grow progressively on the other side of it. To do that seems like it's kind of separating it up into chunks in a way which isn't a very natural way of capturing your experience. So if we just want to say, that you see the object pass behind the occluder, then it's natural to say at T3 that you do see the object. You see the object passing behind the occluder in that way. So that's all well and good, but that's just really using a kind of natural way of describing your experience to try to draw conclusions about what you're representing at the moment when it's behind the occluder. And this, I think, is where philosophy can really helpfully draw on vision science to try and bolster that by consideration of the underlying vehicles of representation and what's going on with them at this stage, what you might think of as object files. So what we're trying to figure out is, do we have good reason to say that the subject is actively maintaining a visual representation? And can we go beyond considerations of first-person report of their phenomenology in order to establish that they are, in fact, maintaining a visual representation of the object? And here, I think it's really helpful to consider work that contrasts this kind of occlusion with a statistically very similar case, but where the object, as it gets closer to the occluder, instead of gradually disappearing in a manner consistent with it disappearing behind it, instead implodes and then explodes on the other side of it. So there's a lot that is in common between these two experiences. In particular, what you start with at T1, what you end with at T5 is the same. So part of what we're interested in is there any difference in your visual experience at T3 in these two cases? So if, as I claim in the case of occlusion, we should say that you see the object when it's behind the occluder, then we want to find that there is a difference in these cases, perhaps, that you don't get in this case where the object seems to be destroyed and then to be recreated on the other side of the occluder. And happily, we do seem to find things that are consistent with that. So Brian Scholl and Zenon Pilishin have some nice work that shows that it's easier to track objects during occlusion than during cases where they're imploding and exploding at the same location. And Flombaum and Scholl have some also very nice work that finds that it's harder to track featural changes of objects, like changes in color or changes in shape, if those objects are imploding or exploding rather than being occluded. So what are we to make of these differences? One way of understanding them is that in the case of occlusion, you maintain the object file, that is to say, you maintain some kind of representation of the object as it passes behind the occluder in a way that you don't in the case of implosion and explosion. And that's what explains why you get better change detection, because those temporal scene fragments are bound together into the same persisting object representation. And so this builds up evidence for a picture on which the representation of the object is maintained in the occlusion case, but not in the case of implosion or explosion. And that's revealed in turn by the profile of things that you can do with it. Okay, so back to our argument. I'm suggesting that the maintenance of a visual representation of the object throughout this extended time period, T1 to T5, including at T3, explains various features of the subject's visual experience of occlusion as compared with implosion or explosion. And so this gives us reason to endorse the claim that the subject is actively maintaining a visual representation, and so satisfying this definition of what it takes to see an object. The subject sees the object at the moment of occlusion, since they're actively maintaining a visual representation of it at that time, despite its temporary invisibility. Okay, here's a major concern you might have at this point. You might say, the representation of the object isn't really visual in this case. It's just a form of memory. So in our criteria of seeing, we've included this proviso that it has to be a specifically visual representation. And you might say, look, sure, we can remember invisible objects. That's not a particularly surprising or interesting conclusion. But what you can't do is you can't see them, because something isn't visual unless it's right there in front of you. And you might want to tie that to it being able to be causally related to the object in the relevant way. But this confronts us then with this really interesting question, which is, how do we distinguish memory from perception? Where is that line going to lie? So it seems like you don't need memory to see, you don't need memory to see, you don't need something to be visible in order to remember it, but you do need it to be visible in order for you to see it. Okay, So how are we going to distinguish memory from perception? This is a tricky task because we know that perception relies on various forms of both short and long-term memory. So the two are definitely intertwined at some level. Is there a way in which we can pull them apart? It's tempting to fall back on some kind of criterion here of a current retinal stimulation. So appealing to our criterion for what it takes to see an object, we might say, look, the object is not causally related to the subject in the appropriate way, unless it is capable of reflecting light in a way that can be picked up by the retina pretty much simultaneously with your visual experience of the object. So we want to allow some kind of lag for processing, but that doesn't need to be very long. And so according to this, then, we can exclude these cases of apparent vision of invisible objects because they're going to fail to satisfy this occurrent retinal stimulation criterion. Now, I can't say very much about this for reasons of time, but I think we're very unlikely to come up with a version of the occurrent stimulus criterion that will do the job that we want it to do, which is to provide us with a kind of satisfying, intuitive way of discriminating between cases of memory and cases of perception. Here's one reason to think that that's the case. So think about cases when you saccade. So that's when you refocus your attention within your visual field by skipping both your eyes across it. So that typically happens several times a second when it happens, so that you don't get a kind of blurry visual experience. The flow of information in the magnocellular pathway is suppressed, but you can't detect that at the kind of experiential level. So at that moment in time, your visual experience is independent of a current retinal stimulation for a brief period of time. But it would give us a fairly bonkers way of discriminating memory from perception if we were then compelled to say that many times a second you are in fact switching between genuinely seeing something and merely remembering. It seems like we don't want to adopt a criterion that's going to give us that kind of implausible stop-start picture of visual experience. Here's another way that we might go in trying to distinguish memory and perception. Perhaps we could appeal to a neural criterion. So we have a good understanding of which parts of the brain are involved in visual perception. So why not do some brain mapping and let that guide us to conclusions in this case? So I want to say a little bit about this option because I think it's a really interesting example of the ways in which psychology and philosophy need to be working together. So Holm and Zecchi have some really interesting work which speaks quite directly to the question I'm interested in. They showed subjects displays in which an image of a face or a house either remained visible while a screen rose behind it, so that's what's happening in this case, or it was occluded to 98% by the screen rising in front of it. And they then measured activity in brain regions over the next 7.5 seconds. And in particular, they were looking at activity in the lateral occipital complex, where activity is particularly associated with object perception, and in the fusiform face area, particularly associated with face perception. And what they found is that activity within the fusiform face area in the lateral occipital complex is invariant to whether objects are occluded or not. The surprise lies in the fact that the areas were activated with the same magnitude and had very similar time courses, whether perceived or not. Now, they conclude from this that activity in these regions indicates awareness of presence rather than perception, as has previously been assumed. But note that they could have gone in the other direction and concluded that visual perception is possible of occluded objects. So an alternative interpretation is that this activity does indicate perception. The objects in question continue to be perceived, even if most of their surface isn't currently visible. So the key point here is just that drawing conclusions from neuroimaging often itself relies on substantive theoretical commitments, which makes it very hard to use neuroimaging to decide those questions. In what time I have left to me, I want to say a little bit about this question of whether we can see ways things could be but aren't currently, so non-actual properties, I'll call them. So in this case, you can see the arrangement of these cars in the car park. What I'm interested in is, can you also visually perceive ways these cars could be arranged but aren't currently? So are you able to visually perceive the fact that this car could drive forward into this space, or that this white car here could perhaps turn and park in between these two? Or alternatively, consider seeing a tower that a child has built that's quite precarious. Are you able to see the possibility that the tower would fall even though it's currently upright? Now, Clearly, we gain information about ways the world could be, but is not currently, from perceptual experience. But what we'd like to know is, does this feature in the perceptual experience itself? And that in turn requires us to reflect again on this question of how do we decide what is presented to us in perceptual experience and what we just infer from it. So Haffrey and Firestone have a really nice list of signatures of perceptual processing in a recent paper on whether we can perceive relations. And I suspect that many of these are satisfied for our perception of some non-actual properties. But what would be really great is if we had an even stronger conclusive reason to think that we get to perceive these properties. And so in the last 30 seconds, I want to throw one out there because I'd be really interested to know what vision scientists think of this. So is it possible that perception of possible properties could be partially constitutive of what it is to see something as an object? So both vision scientists and philosophers have suggested that what it is to see something as an object is to see it as a bounded cohesive particular, but it's very hard to come up with a list of necessary and sufficient conditions for that. We can appeal to some of these, but you can have them in the absence of actually seeing something as an object and vice versa. So instead, perhaps we can give an account of boundedness and cohesiveness in terms of your perception of possible properties. So could it be that seeing something as an object makes available a host of anticipations for how that object might behave, and that in fact some of those are constitutive of what it is for you to see it as an object? That just is for you to see it as having a certain set of possible properties, like a disposition to move or behave in certain ways under non-actual circumstances. I have to wrap up at this point. So I started off by talking about whether we can see invisible objects. And I think the key upshot of that is that far from living in the present, an entwinement with the past is inherent in the most basic of our perceptual capacities, our perception of objects in the world around us. Then I've talked about whether we could maybe see modal or non-actual properties. That, I think, suggests that visual perception is not just to know what is where by looking, nor is it to represent how things are in space, but also what things could be, how they could be. I think in both cases, this moves us towards an understanding of visual perception as a process of dynamically modeling the world and away from a model of it on which we're just passively reflecting the world. Thanks very much.
Thanks, Jesse, for a super interesting talk. And Phil, you can go ahead and start sharing your screen. So our comment will be from Phil Kelman, who is a distinguished professor of psychology and the current cognitive area chair in the Department of Psychology at UCLA. He's done foundational research on the topics of amodal completion, shape perception, and object perception. So you can go ahead and get started, Phil. Thank you. And unmute yourself, please.
Yes. Okay. Can you hear me now? Yes. Well, first I want to thank Kevin and Chaz for organizing this event and Karen and Jorge for chairing. Very happy to be part of this. And I think there's a lot of value in having philosophers and vision scientists talk to each other. So hopefully this will be the beginning of a continuing event. It was great to read Professor Mutton's paper and hear her talk. I think that there are a lot of issues in this. I'm going to focus on two of them. Can we see invisible objects, and is perception dynamic? But some of what I say will have implications for the others. So vision science suggests actually that seeing the invisible, according to the criteria that were given, is actually pervasive. One thing I do want to mention is, in looking at the question of whether an object over time that becomes invisible is really perceived, we can generalize that argument as well to space. So for some of these frames, such as B and D here, only parts of the object are visible. So technically, the parts that are hidden would also be invisible by the criterion. So I'm going to talk about both of those. But one thing I would like to do is extend the domain here. So some objects don't even exist in momentary views. So this helps us to understand both the perception is dynamic and get at this issue of the invisible. So here's a classic oldie but goodie example of structure from motion. You're going to see dots moving on a two-dimensional screen, but their relations will give you a vivid three-dimensional structure. That structure doesn't exist in any stationary view. It's just dots. Actually, it's an old video with streaks, but if it's done right, the 3D structure is only a result of the motion. Now, digressing for a moment into space, vision scientists deal a lot with objects that are partly invisible, and we know that there are perceptual processes that complete objects behind occluders and in illusory contours in front of other stimuli. This gives us the unity of objects, continuous contours, perception of shape. Kind of putting these together, in spatiotemporal object formation, the objects are actually created over time. So here, this ghostly object, always show it in classes around Halloween, has continuous boundaries and shape, but most of it is not even specified at all in the places where there are gaps. And also all of what you're seeing comes from the changes in these little rectangles. Some of the stationary views showing you what perception at various moments might look like gives you an open area in these places, but not a bounded object. You can actually pile these on top of each other. I'm going to show you an illusory contour display, kind of a classic Kanitsa triangle, but with a twist. The inducing elements for this don't exist in momentary views. We're going to create them by motion over time and accretion and deletion of texture. So, apologies for the old digitized, the VHS videotape that was digitized. The central triangle you see, those edges are in your head, created by perceptual processes. The elements that produce them are also created over time. So is seeing the invisible a problem theoretically? And how about dynamic seeing? It depends on your theory of perception. I thought Professor Mutton did a really good job of describing this little parody of a theory, or it's a real theory, but it's not as current today. A very old theory suggests we get rays of light. They activate receptors. These receptors give you local sensations. And the problem of perception is this thinker back here trying to figure out what could cause these sensations, maybe using associations or memories to figure that out. A legacy of this kind of thinking, even though I don't think anyone would subscribe exactly to this theory today, a legacy is the atomism that Professor Mutton mentioned and the issue of the occurrent stimulus. Is there really something in that point at that moment that corresponds to your percept? I think that's a bad legacy. A more modern view, which I think, despite differences, applies to most current theories of perception, is that we use information that consists of relations in space and time. And then this information that is in the stimulus, but isn't the elements of the stimulus, is used by perceptual mechanisms to give us perceptual representations. So this has been a hard-won change in vision science, and many thinkers have contributed to it, all the way back to Herring, but also Gestalt psychologists, Gibson, Michaud, Kanitsa, and Marr, and others. And we come to the idea that spatial and temporal relations provide information used by perceptual mechanisms to produce perception of properties and structure of objects and events. So Michaud talked about perceptual completion, but also amodal perception. Gibson talked about sensationless perception. So here's a little schematic of this. Perception is about relations in space and time in the information. Perceptual mechanisms produce perceptual representations. Now you might be thinking here at VSS, who would make such a slide? This is so obvious today. Well, I think having this in front of us helps us avoid two subtle legacy issues. One is there is simply no requirement in this formulation for point-by-point correspondence between perceptual representations and elements of stimulation or sensations, either in space or time. And secondly, there are really no a priori limits on the complexity of the relations that might be used, nor on the ecological complexity or meaningfulness of resulting descriptions. Thus, whether we can perceive causality, animacy, or social interactions will depend on what perceptual mechanisms we have, but it is not ruled out by one's theory of perception. Now, I'd like to apply this to one last issue, which is kind of how general are relations in perceptual processing, and what is really given in perception, and then what must be inferred. So these categories are from Professor Mutton's presentation. She said some people think shape and color are uncontroversially given or perceived, but other things are more controversial. I want to suggest that relational processing is more involved even in the simple and more obvious given parts of perception than we often suppose. In studying contour perception and contour interpolation, it's common to say, here's a real contour. That's really there. Here's an illusory contour. And here's an occluded contour, which some have thought at different points in time might be inferred or cognized. It's really something we assume or think about. Well, I'd like to tell you that all of these are actually represented. And maybe the most important way to see that is look at the real contour. So here's a simple open contour. And we know from work in vision science that in early cortical areas, this is encoding by local oriented detectors. At any given point, they differ in spatial frequency, and they also at any given point differ at the orientation within each spatial frequency. So this is a large population of separate detectors that's firing. Should also tell you that the bandwidth in terms of orientation of these detectors might be as large as 40 degrees. So it isn't the case that the orientation you see anywhere along this contour is being given by some single detector. The perception of orientation anywhere here is a resultant of a computation involving many detectors and relations among their outputs. Moreover, seeing this as a contour token, seeing it as a unified entity, despite all those separate local receptive fields, this is a computation as well. So even so-called real contours are computed and represented rather than simply given. And I thought Professor Hurlbert made this point eloquently about color constancy. So in terms of the actual light coming to your eyes in this classic demonstration from Lotto and Purvis, these two patches are giving exactly the same amount and qualities of light to the eyes, and yet they look very different. And here are two screenshots on the side of what they really are if shown on the white background. So even something as simple as color, which is pretty much on many people's lists of what's given or a low-level property, that is actually the result of complex computation, if we mean color in the world and color of a surface. So can we see the invisible? And can we perceive based on information across time? And something I didn't talk much about, can we perceive causality or animacy and so on? I think the answer to all these questions is yes, because given appropriate information, perceptual systems utilize spatial and temporal relations in the input to derive representations of useful, meaningful structure in the world, or put much more simply, it's relations all the way down. Thank you.
Thank you, Phil, for that super thought-provoking commentary. Again, we have a gazillion of super fantastic questions. I'm going to call on Rashawn Reeder first. You can go ahead and unmute yourself. Or I can do it.
Hi, yeah. Again, it was showing that I wasn't able to unmute myself. My question for Jesse, and I feel like this was kind of touched on in the comment, is knowing something is likely to be there. So in the T3 scenario, when the object is invisible, is knowing something is actually there, is that the same as seeing it? Because someone with a blind mind's eye, someone who doesn't have any visual imagery, aphantasia, they can't have an actual visual representation of the object. It's a representation, not necessarily visual, and it could be a spatial or temporal representation. But is that the same as seeing it?
Yeah, I would want to say definitely not, that there are all sorts of cases in which you might know that an object is there, or you might represent it in certain ways, but it doesn't amount to a visual representation. So then we want to know, well, what makes it a visual representation? And I think I would tie it to two things. So one would be that you do want there to be some kind of causal relationship that goes via certain visual processes that relates the object to the individual, but also that it needs to be reflected to some degree in your visual phenomenology. So you have some kind of visual experience, and there at least needs to be some kind of relationship between the kind of representation that we're attributing to the individual and the kind of visual phenomenology that they're enjoying. Yeah, visual aphantasia is a nice example. Thanks for that.
I'm muted. Thank you. We're going to take one more question. Brian Scholes, you want to go ahead and ask your question? And I am unmuting you.
Hello, Jesse. You're at VSS. This is so exciting. I had a question that is an attempt to highlight an opportunity for synergy across your talk and Ned's talk. Both you and Ned at different parts talked about objects moving behind screens and sort of what we see and what we notice. You ask whether we see, when an object moves behind the screen, do we still see it while it's behind the screen? And I just want to focus on the it for a second. The work that you talked about shows in part that we do continue to see and represent the object, but at the same time, we might not be able to still see and represent all of the individual properties of that object. In fact, when you're tracking multiple objects through occlusion, you can actually change all of their colors as they move behind occluders, and people will, adult people will not even notice that. And so I wonder if this raises the possibility that the question is actually more multidimensional that you're asking, Jesse, that maybe we see it like the persisting reference, the persisting individuality of that entity, but we don't continue to see all of those properties. And a related point for Ned then is if even adults don't notice properties like color change, despite having conceptual competence, maybe that weakens the argument from the infants not noticing. Thanks, Jesse.
Hi, Brian. Yeah, thanks for that. Yeah, no, I think that's absolutely right. I mean, I think I hesitate to move too quickly between the fact that an adult fails to notice something to the conclusion that they haven't seen it. But I am entirely on board with the idea that you may be continuing to have a kind of visual representation of the object, but not necessarily of its properties. And I think that's quite consistent with other times when we might say that you see an object. So when you see somebody in the distance, you might be able to pick out very few of their kind of visual properties until they get a bit closer to you, but that doesn't stop us from saying that you see them or that you see the object. Though it does seem like intuitively we want some degree of sensitivity to some of an object's properties if we want to say that it's a visual representation. So I'm not sure how sparse we can go there before we begin to feel like, hang on a sec, I'm not sure this is really visual in the way we want it to be. But I think I agree by and large with the gist of it, and I appreciate the point of synergy between me and Ned.
Can I jump in just for a second and add to that we might want to get past this idea that we're trying to construct a visual world, an auditory world, and et cetera.
Mm-hmm.
And in fact, the seeing is an object moving through space and time, and that's what's preserved. A lot of our vision goes toward a spatial representation, and other senses feed into that as well.
So, Brian, the Wilcox paper that I mentioned reports that by 11 and a half months, babies are surprised when in these tunnel effect situations, when a red thing turns into a green thing. So I'm sure there are circumstances in which people don't notice the change, but there are also circumstances in which they do.
Fair enough. I also just wanted to say, Chaz, you started out by saying that part of the goal of this was for philosophers to identify important questions for us. I feel like Jesse just did that in terms of the how much does it take argument. That's very inspiring. Thank you.
Great. Okay. Well, I'd like to thank all the speakers so far. I'm going to now pass it over to Jorge, and I'm also going to back channel send him all the questions that you've sent so far, so he has those for the general discussion. So thank you all, and goodbye.
Wonderful. Thank you, Karen, and thank you, everyone. Now, we're going to hear EJ Green, who I invite you to start sharing your screen. EJ is an assistant professor in philosophy at MIT. And EJ is a wonderful and prolific philosopher of perception whose work, like that of the previous speakers, beautifully integrates innovative philosophical approaches to perception and cutting-edge cognitive science. EJ has published in most, if not all, of the top journals in the discipline, and his work deals with shape perception, attention, the perception of structure, the cognitive penetration border, and multimodal perceptual integration, which is what we're going to hear about today in his talk, Rethinking Molyneux's Puzzle, where EJ will offer a new perspective on a classic problem in perception. So EJ, the floor is yours.
Thanks, Jorge. And thanks to Kevin and Chaz for organizing this great event, which I'm really enjoying. So let me just get right to it. So imagine that you first see a globe, and then you close your eyes and you hold it in your hands. So in both cases, you perceptually represent the globe's shape. Moreover, numerous studies have shown that human perceivers have the ability to recognize shapes across modalities. So shapes that are first seen can later be recognized through touch and vice versa. But what exactly is the relation between our visual and tactual representations of shape? So philosophers have long been fascinated by this sort of question. However, the bulk of the philosophical literature on this question has been shaped to a considerable extent by a letter that William Molyneux, an Irish politician, sent to John Locke in 1693. Well, actually sent two letters, one in 1688 that Locke never replied to, and then another one in 1693 that Locke thought was worthy of his attention. So that letter goes as follows. Suppose a man born blind and now adult and taught by his touch to distinguish between a cube and a sphere of the same metal and nighly of the same bigness, so as to tell when he felt one and the other, which is the cube and which the sphere. Suppose then the cube and sphere placed on a table and the blind man made to see, so he suddenly granted vision. Where, whether by his sight before he touched them, he could now distinguish and tell which is the globe, which the cube. So Molyneux is asking here about a particular sort of test that we might perform on a newly cited subject. But presumably this test was not offered as just some kind of peculiar curiosity. Rather, it's taken to have some bearing on issues of more fundamental theoretical significance. But there's no universal consensus about just what issue Molyneux intended to raise. And I'm not a historian of philosophy, so I'm not going to try to kind of settle that question here. However, as a matter of fact, many people have taken Molyneux's test to bear on a particular question about how normal human perceivers, kind of normally sighted perceivers, are able to represent and recognize shapes across modalities. So specifically about the relation between the visual and tactual representations that are responsible for or are involved in our ability to recognize shapes cross-modally. So in a paper by John Schwenkler, he puts the issue like this, and I think that this does accurately characterize the way a lot of philosophers have thought about the issue Molyneux was raising. So think of the way that shape and other spatial properties are perceived in sight and touch, of how we can tell right away whether a seen shape is the same as some felt one. Molyneux's question asks, can we do this only because of learned associations built up in the course of past experience, or are the representations of these properties related somehow intrinsically? That is there some kind of intrinsic similarity between the representation of shape in sight and touch? So I'll put Molyneux's puzzle this way. So what's the relation between the visual and haptic representations of shape that support our capacity for cross-modal recognition? Okay. So as regards Molyneux's puzzle, we could distinguish four possible answers. So I'm not claiming that these options are exhaustive here, but many of them have at least kind of gained some proponents in the philosophical and psychological literature. So one view is the brute association view, on which there's no intrinsic similarity between our visual and haptic representations of shape. Any connection between them is just kind of the result of past history of association. So this view is most popularly associated with George Berkeley. So Berkeley, for example, held that the relation between the visual representation of a square and the haptic idea of a square is just as arbitrary as the relation between a word in natural language and the object that it signifies. A second option would be structural correspondence. So perhaps visual and haptic representations of shape are distinct, but they're structurally similar. Perhaps they're kind of composed of the same number of parts that are related in similar ways. And on the basis of this, the perceiver could sort of draw reasonable inferences about what the right mapping is between them. And so that view was charted out by Leibniz. A third option would be rational correspondence. So perhaps visual and haptic representations of shape are distinct, but they're rationally related. So no subject could rationally doubt that they represent the same properties. So you could think about this on analogy to two geometrical descriptions in natural language that are different, but sort of semantically or analytically equivalent. So like closed four-sided figure versus closed four-angled figure. And then the final option is type identity, which says that at a certain stage, the visual and haptic representations of shape are identical. So the very same representations can be generated from inputs to either modality. And so the type identity view has not really had all that many proponents in history of philosophy, but I want to argue that the literature, the empirical literature, does make a fairly compelling case for it, but that the case for it does not go by way of Molyneux's test. So if we wanted to just kind of coarsely classify these, the brute association view would say that there's just no intrinsic similarity at all between visual and haptic shape representations, whereas the other three views all assert some form of similarity, but vary in exactly what that consists in. All right, so just plan moving forward. I want to argue first that if Molyneux's test were to be a good way of resolving Molyneux's puzzle, then a condition that we can call the match principle would need to hold. However, the match principle probably does not hold, and the empirical evidence provides a lot of evidence against it. However, I want to close by arguing that perception science has made considerable progress toward resolving Molyneux's puzzle in other ways, and such research provides some support for the type identity view. All right, so here's one much discussed study by Richard Held and colleagues, 2011. So they looked at 5 newly sighted subjects within 48 hours of surgery for congenital cataracts, and they were tested on a match to sample task in 3 different conditions. So in each condition, subjects first encountered one shape and then encountered a pair of shapes and had to report which of the pair matched the one they encountered earlier. And there were 3 conditions. So one where both the sample and test shapes were presented visually, tactual, where the sample and test were both presented tactually. And then finally, the tactual visual condition, where the subjects first felt a shape, and then they saw a pair of shapes and had to report which one they saw matched the one that they felt earlier. And so this one was critically supposed to be kind of the best operationalization of Molyneux's test. Now, the results were striking and interesting. So subjects were highly accurate in both the visual and tactual cases, so performance was above 90%, whereas in the tactual visual case, subjects were nearly at chance. Okay, so in matching a seen shape to an earlier felt shape, they didn't clearly have the ability to do that. And so Held et al. Concluded, our results suggest that the answer to Molyneux's question is likely negative. The newly sighted subjects did not exhibit an immediate transfer of their tactile shape knowledge to the visual domain. Okay, cool. So a number of people kind of in the follow-up to this study have wondered whether this really settles Molyneux's test in the negative. So arguably in imagining his setup, his scenario, Molyneux was imagining a case where the newly sighted subject could see well enough to clearly visually represent the full 3D structures of the globe and the cube. But some authors have suggested that, well, maybe the subjects just didn't meet this condition because maybe they couldn't see well enough to represent 3D shape under static viewing. Maybe they had deficits in depth perception that made recovering 3D structure too difficult. And so in light of this, some authors like John Schwenkler and Kevin Connolly and others have suggested possible ways of refining the experiment, maybe using raised line drawings or shapes on a rotating platform, etc. So I'm not going to get into this issue too much here. Instead, I want to ask a more basic question. So my question is, should we even bother trying to perfect Molyneux's test if our goal is to resolve Molyneux's puzzle? And I contend that Molyneux's test could only bear evidentially on Molyneux's puzzle if a condition of the following sort were met. So the match principle says that newly sighted perceivers form visual and tactual representations of shape that are intrinsically like the visual and tactual shape representations responsible for cross-modal recognition in normally sighted perceivers. And so why should the match principle be needed? Well, suppose we have the newly sighted subject over here and we have the normally sighted subject over here. And let's just suppose for the sake of argument that both subjects can form full shape representations through both vision and touch. Molyneux's test tells us most directly about this relation over here, okay? Whether the newly sighted subject's visual and tactual shape representations display a sufficient similarity to enable transfer of recognitional knowledge across modalities. But Molyneux's puzzle about our ability for cross-modal recognition asks about this relation over here. Okay, so what's the relation between our visual and tactual representations of shape? But for this relation to bear on this relation, we would need to know whether the relata of the relations were sufficiently alike. So suppose, for the sake of argument, that the visual representation of shape is significantly different in newly sighted subjects from normally sighted subjects, then any intrinsic similarity that's present over here might be absent over here due to that difference. Okay, so the match principle then could be understood as saying that Molyneux's test only bears on Molyneux's puzzle if newly sighted subjects form visual and tactual shape representations that are like ours, except that they have not had the opportunity to learn mappings between these representations. And it's pretty clear if you go back and read Berkeley, for example, that this was the sort of setup that he had in mind. The idea is that the newly sighted subject was supposed to have representations that were just like ours intrinsically, but they had not had that history of association. But the problem is that we have strong reasons to doubt the match principle. So my argument is going to proceed in two steps. So first, I'm going to go kind of rapid fire through just a bit of evidence on cross-modal recognition in the normally sighted. Again, this is not going to be comprehensive. Can't do everything in 20 minutes, but I want to point to a few features that seem to be present in cross-modal recognition in the normally sighted, and then argue that the sorts of deficits that are observed in newly sighted subjects should make us skeptical of their ability to form representations of that sort. So there's some recent evidence that cross-modal recognition in normal perceivers relies on representations that are both view invariant and part-based. And those properties are indicative of, paradigmatically, of a high-level structural scheme of shape representation that's fairly sophisticated, in which shapes are represented in terms of their component parts and how those parts are related to one another in an object-centered or allocentric reference frame. So here's a study by Lacey and colleagues, 2007. So subjects either saw or felt 4 sample objects at a fixed orientation. So they either saw them at a fixed orientation or they were feeling them and the objects stayed put at that orientation. And then after familiarization, they either saw or felt a test object and they were asked to say which of the 4 samples it matched. And the test object was either at the same or a different orientation, rotated either 90 or 180 degrees. And the interesting result was that while recognition, as one might expect from decades of research, was orientation dependent within modalities, it was orientation invariant across modalities. So changes in orientation did not affect, say, the ability to recognize via touch an object that the subject had earlier seen. And so this sort of result has been replicated in other studies as well, and is taken to suggest that the representations responsible for cross-modal recognition are view invariant. Okay, so the same representation being produced regardless of the object's orientation. Now, just really quickly on the part-based bit. So a couple of recent studies by Erdogan and colleagues, 2015 and 2016, showed that both cross-modal shape similarity ratings, so for example, when one shape is seen and the other one is touched and the subject rates their similarity, scale of 1 to 7, and also bold activity patterns in lateral occipital cortex were governed by part structure. So objects were rated as more similar across modalities to the extent that they shared underlying part structure. And also LOC activity patterns were more similar both within vision and within touch as underlying part structures were more similar. Okay, so I won't go through the details there, but just some interesting evidence for part-based shape representations across modalities. So now I want to get to visual impairments in the newly sighted. So my argument is that newly sighted subjects are impaired in a variety of mid-level visual functions, but specifically in the sorts of functions that we would expect to be involved in forming structural shape representations. So to the extent that those sorts of representations are involved in cross-modal recognition, we should be skeptical of the match principle. So here's a study by McKighton and colleagues, 2015. So they did this oddball detection task where the subject saw an array of objects and they simply had to say which one was the oddball different from the rest. And they looked at both at low-level conditions where the oddball differed in some low-level feature that you might expect to be available in early vision, like color, size, shape, 2D shape, that is. Or they looked at mid-level conditions where the oddball differed in amodal completion, shape from shading, 3D structure, 3D orientation, or subjective contours. And what they found was that the newly sighted subjects, while they were no different from normal subjects on the low-level tasks, they were significantly impaired in the mid-level tasks and in most cases indistinguishable from chance, suggesting that mid-level visual processing either hasn't come online yet or is just, impaired. Perhaps there's a critical period when it comes to newly sighted subjects. Now, more to the present point, here's a study by Huber and colleagues, 2015, of subject MM who lost sight at 3.5 years old in a chemical accident, a chemical explosion, and then his sight was restored at age 43. And they looked at a variety of different tasks, but among them, the ability to match 3D shapes across depth rotation. And in that case, MM was significantly worse than controls and also indistinguishable from chance, and also was impaired in matching 2D shapes across picture plane rotation. So what this suggests, I think, is that newly sighted or sight restored subjects likely have an impaired ability to form view invariant representations of shape through vision. And that presents a problem because we just saw some evidence that the representations responsible for cross-modal recognition in normal perceivers are view invariant. And this evidence casts doubt on the ability to form those sorts of representations in the newly sighted. Now, just really quickly on the part-based stuff. So it's known that sophisticated principles of perceptual organization are involved in constructing part-based shape descriptions. So the principles have to specify how an object, a privileged way of parsing an object into parts. However, there's a lot of evidence showing that visual parsing in newly sighted subjects is significantly impaired relative to normally sighted subjects. So newly sighted subjects, according to Ostrovsky et al., 2009, seem to parse scenes in accordance with really simple rules of shared luminance. And so regions that differ in luminance are parsed into different objects. And so they have an inability to kind of unite those fragments into single kind of overarching perceptual units. And so Ostrovsky et al. Write, a robust object representation is difficult to construct on the basis of such fragments. And I would say that this makes the kind of construction of complex part-based shape representations unlikely in these sorts of subjects. Okay, so just to evaluate the match principle. The match principle requires that newly sighted perceivers form shape representations intrinsically like the ones that we use for cross-modal recognition. But the evidence, I think, casts doubt on this principle. And so Molyneux's test probably can't be used to resolve Molyneux's puzzle. So assuming that that's right, and that's always dangerous in this sort of context, but how can we resolve Molyneux's puzzle if we can't use Molyneux's test? And my suggestion is that we should just give up on trying to find a critical experiment for resolving this question. The best we can do is to appeal to standard sources of evidence concerning the functional and physiological processes responsible for cross-modal recognition in normally sighted subjects. And here, I think some recent data provides interesting support for a convergent processing model on which both modalities start out with low-level modality-specific representations of shape, and then there's a convergence on high-level multisensory representations of shape that are shared across modalities and kind of can be generated through either visual or tactile input. Okay, so a number of authors have defended models of this sort. And so why should we believe that kind of model? Well, so there's just a couple of sources of evidence that I'll talk about really quickly in what time I have left. So first, there's physiological evidence suggesting that both visual and haptic shape processing recruit shared areas of lateral occipital cortex. So a number of different studies have shown that. And also some studies showing that the actual patterns of activity in LOC are similar across modalities. So if you get a classifier to learn to decode shape on the basis of visual input, it can then decode that shape on the basis of tactile input as well. So that's this Erdogan et al. 2016 study. So further behavioral evidence suggests that there's automatic transfer of acquired recognitional abilities and category knowledge from vision to touch and vice versa. and that this seems to hold both in infants, so this is this Streri and Gentaz 2003 study, and also in adults. There are studies showing optimal integration of visual and haptic shape cues to form a multisensory estimate, which I think makes the most sense if the multisensory estimate is one that's sort of not kind of proprietary to either modality, but genuinely multisensory. And then finally, recent Bayesian computational models characterize the formation of shared visual haptic shape representations from sense-specific input signals, and have been shown to have a kind of good fit to human shape similarity ratings. Okay, so all this I take to provide some evidence that there are shape representations that are constitutively multisensory. They're shared across modalities and activated through either visual or haptic input. And so that would be a version of what I earlier called the type identity view. Now, some further questions that we might ask, and where I think that there's really nice opportunity for discussion between philosophers and vision scientists is, well, if we have these kinds of shared representations, then why is the phenomenology of shape? Why does it seem so different across modalities? And how do we describe that difference? Furthermore, are shared multisensory representations innate or acquired? And does that issue matter to kind of any of the philosophical questions about perception? And then finally, should Molyneux's puzzle be resolved differently for different sorts of shapes? So, you know, the obvious distinction would be between part-based shapes versus kind of shapes that don't allow for an easy kind of analysis into parts. Perhaps there's a different story there. Okay, so that's it. Thank you.
Thank you so much, EJ. Now we'll hear comments to EJ's talk by Professor Ladan Shams, who's a professor of psychology, bioengineering, and neuroscience at UCLA. Her laboratory investigates how the brain integrates information from different sensory modalities into coherent percepts using behavioral and neuroimaging methods, as well as mathematical model. So, Professor Shams, take it away.
Thank you, Kevin and Chaz, for organizing this very enjoyable workshop and for introducing this interesting format to the VSS community. I am going to start by saying that I agree with most of the points, the main points that EJ made, as I have summarized here. Visual representations that are shortly available after sight restoration are not the same as the representations that are used by normally sighted adults. And this makes the answer to Molyneux's question somewhat irrelevant to understanding the mature object representations that normally sighted people use. Molyneux's test is not necessary to gain insight into the nature of shape representations, and EJ very nicely summarized some of the studies that have already shed light on these representations. I also agree that human visual object perception probably uses multiple representations, including holistic and structural. I don't agree with the assertion that visual representations involved in cross-modal recognition are necessarily structural. And here I've shown some examples of objects that most probably are not represented in a structural way, and some tasks like subordinate object recognition that rely on features like texture and metric information that we are capable of doing and we are capable of recognizing cross-modally. So I think cross-modal recognition is possible and can operate on any kind of representation as long as there is a connection, there is a link, an association or similarity between the two representations. Now, going back to Molyneux's question, I am going to use my remaining few minutes to offer a slightly more multisensory perspective, which is consistent with EJ's take and will hopefully reinforce his conclusions. I'm going to argue that Molyneux's question as a thought experiment in the 17th century was a valid question. But as a platform for real experiments in the 2020s is probably not going to be very informative. And the reason is that the traditional paradigm of perceptual processing that is modular, bottom-up, and vision dominant has given way over the last 20 years or so to a paradigm that is integrative, non-hierarchical, and multisensory. But the traditional paradigm, because it was so dominant for so long, for so many decades and a couple of centuries, is so ingrained in our minds that even today, even after this transition to the new paradigm, it's very easy for us to fall back into that mode of thinking. Here I'm showing that traditional paradigm in a schematic way. And you can see that each modality has its own pathway, and there is no connection, no interaction, no collaboration between these modalities. And vision is the dominant dominant sensory modality. Now, in the context of Molyneux's question, this means that the haptic pathway processes haptic information and reaches a conclusion or interpretation that the object is a cube, for example. And same thing in the visual pathway, the information is processed and it converges to an interpretation which is consistent, the object is a cube. And this convergent or this common interpretation or representation is the basis for cross-modal recognition. In the newly cited, the haptic information is processed the same way, and it leads to the same interpretation, object is a cube. The visual pathway processes information the same way, but because of the absence of prior experience, it's not clear whether these representations map onto the same interpretation or to a different interpretation. And this question depends on the similarity between these high-level representations. So within this framework, Molyneux's question is a very reasonable question. But still, it makes two assumptions, or testing this question requires making two assumptions. One is that as soon as visual information becomes available, it's like turning a switch on. The visual pathway kicks in, operates, and the individual is able to see. And this by itself assumes that everything is hardwired and immutable. But the second requirement or assumption is that the individual has not experienced the world and there has not been an opportunity to form visual haptic associations. And I'm going to argue that these two assumptions or requirements are contradictory in nature, and therefore Molyneux's question cannot be answered in a satisfactory way. The reason is that seeing as we know it may require visual haptic experience to begin with. And this idea is not new, it goes back 300 years. And in recent years, there have been several studies that have provided direct or indirect support for this kind of speculation. For example, a study by Dave Burr, Monica Gori, and their collaborators showed that touch dominates vision in some visual tasks in early childhood, even when touch is less reliable and less precise, suggesting that touch is used as a teaching signal for visual development. And we already know that the visual system uses some information such as convergence, some convergence cue for spatial perception. And these kinds of cues can only be informative or operational if they are calibrated by active vision and haptic information. More recently, there's a very nice study by Robbie Jacobs and his collaborator that using neural network simulations showed that visual haptic training is superior to visual training in learning invariant visual representations that are important for object recognition, for invariant object recognition. My lab and a few other labs in recent years also have shown that multisensory experience modifies the subsequent unisensory processing and shapes unisensory representations. So the remaining questions, or the open questions, are what are the rules of the game? What are the computational principles that govern this process? And what are the neural mechanisms that are involved? I'm going to end by reiterating that the traditional view or the traditional paradigm of perceptual processing is wrong. And the real perceptual processing is, as schematized here, involves interactions between modalities at various stages of processing, starting from early stages all the way to high levels of processing. And for this reason, we can't even assume that the haptic representations in newly sighted individuals is the same as the haptic representations in normally sighted, let alone visual representations. So comparing the perceptual processing in newly sighted and normally sighted individuals is like comparing apples and oranges. Thank you.
Thank you so much for that. So we're now technically into general discussion time, but I think we can incorporate one or two questions to EJ in particular, and then we'll use the same method, like just send me in the chat your questions to broaden the discussion after that, to include questions remaining from the previous talks addressed to the other speakers, but also to zoom out a little bit and talk about the relations between psychology, vision science in particular, and philosophy. So if you have questions about that, that will be great if you can send them to me in the chat. And for now, I'm going to ask Ruth Rosenholz to unmute herself and ask her question.
Hey there, I enjoyed both of those last two talks. I think a lot of good points were made, and I particularly do like this abandoning in some ways the match principle. I think that was a really good point. So the question I have is, there's been various arguments made, particularly in the last decade or so, that certain aspects of visual processing are optimal in some sense. For, optimized for the wide range of tasks that you have to perform and stuff, you would presume that the representations in haptics would also be in some sense optimal. What do you think of, does that alone imply that the representations should be similar in the two?
Yeah, that's a great question. So I think that from the standpoint of optimality, you might well expect a system to perform shared multisensory representations, simply because the system has all these different kind of cues to shape available to it. So why would it not combine them to kind of form kind of the most reliable, most precise representation that it could in light of all that information? I guess I was thinking optimality. So if you had separate kind of vision specific optimizing and touch specific optimizing, that wouldn't entail that you had a single multisensory representation. But to the extent that the optimizing kind of spans across modalities, then I think that would definitely speak in favor of the type identity view. It fits I think it fits most cleanly with that view. Of course, you could have kind of duplication. You could have, say, these representations informing one another but remaining separate. But yeah, it does seem to be a less parsimonious model.
Wonderful, thank you. Now I'll ask Jonathan Cohen to unmute himself, ask his question.
Okay, I think I'm unmuted and visible now. So thanks. I have a question for EJ. It was a really great talk. I have a question about the way you're thinking about the relevant representational types. So I guess I've come to think that with respect to Molyneux question, I really favor a kind of retail rather than wholesale approach, because just in case after case, the details about what transfers cross-modally, even with a fixed pair of modalities, just differs a lot depending on the details of the case. And that gets even worse when you start varying up which pairs you're considering. So just for example, one among many ways to think about this is with respect to characteristic illusions. So in vision, there are lots of famous visual illusions with respect to form, like Mueller-Lyer or whatever. And like, it seems like a lot of them do transfer in sort of detailed way over to the haptic case. And you can, but on the other hand, you can run conditions that pull apart the behaviors with Mueller-Lyer stimuli. For another kind of example, think about visual examples like the Poggendorf illusion and the vertical horizontal illusion in vision. You try to run those in audition under sensory substitution. Things break down in like 10 different ways, and it's sort of complicated to say what's going on. So, I mean, I guess this really, for me, has a repercussion for the question about how to do the typing that you're concerned about. So if you think about what needs to be included in the type, if you go for a very expansive characterization, then I think it's unlikely that you're going to get type identity very often at all. But as you start to loosen that, maybe you'll pick up more. And my gut instinct would be, don't give any universal rule here. Just tell me what you're interested in first, and then we'll figure out the right way to do the typing depending on that kind of a question. But it sounded like you actually had in mind a more stable way of thinking about the typing. Are you open to this kind of flexibility, or do you really have something stable in mind? And if so, what is it?
Great. Yeah, so there's a lot built in there. So so first, I think great question. I think that I'm open to the possibility that the kind of representation that's shared cross-modally could end up being kind of more abstract and qualitative. Certain metric details might be kind of omitted or something like that. And so that would leave room for certain metric illusions being different between vision and touch, as you mentioned, like the Poggendorf or the Mueller-Lyer case. The other thing, though, is I think that the question of whether there are certain representations of the same type can be produced through input to either modality is maybe distinct from the question of whether any individual stimulus would elicit the same representation type through both modalities. And so it could well be that, in the Mueller-Lyer case, there's a representation type that's produced through vision that the very same stimulus would not elicit through touch, but there is some different stimulus that would elicit that representation type. So I'm not saying that's true. I just want flagging that as an option in logical space. But there's a lot there, and I don't think I'm going to be able to fully answer all the questions you raised. But yeah, thanks.
Wonderful, thank you. So I think we can have a short discussion with more questions about some of the previous talks. I think I'm seeing like some common threads involving some of the previous discussions that maybe people want to ask those questions. So I'm going to ask Rebecca Keller to unmute herself and ask her question that she had for Jesse.
I'm sorry, Jorge, if I can have like 30 seconds to comment on the last two questions real quick before we go.
Yeah, 30 seconds it's perfect.
Okay.
Yeah.
Okay. So I'm going to share my screen because I want to show this slide one more time. Okay. So I think in terms of optimality, it is true that, study after study shows that perceptual system is statistically optimal in a lot of tasks that we explore, whether it's visual modality or other modalities. In terms of whether we have to have the same representations to achieve optimal processing, that I'm not sure whether we can. This answer is as simple as that. Here I'm showing a graphical model that Robbie Jacobs and I basically used as a framework for exploring some of these questions several years ago. And what the Bayesian approach would propose is that the ultimate goal of perceptual system is to estimate what's going on out there in the world. So the ultimate goal is to estimate these environmental variables that happen to be most of the time amodal, whether it's the size of an object, the shape of an object, the other properties, the smoothness of an object, all of these things that are amodal and can benefit from information from different sensory modalities. And so,
sorry,
yeah. Yeah. So basically,
maybe we should move on to
right.
the next question, or maybe you want to wrap up the comment.
Yeah, I'm going to wrap up by saying that all of these modalities would have to make an inference about these high-level variables, environmental variables. So at some level, there has to be a common representation inevitably if we are to make inferences about what's going on in the world. So that's the Bayesian approach, and I think which has found a lot of traction in the field in the last couple of decades.
Thank you. So yeah, there are lots of questions around memory and vision for Jesse's talk. So I'm asking Rebecca Keller to unmute herself and maybe ask her question, because I think it captures some of the other worries that other people have.
Yeah, so I am totally convinced by that you see the invisible object when it's going past the occluder. When I read the paper, I was like, course, obviously. My concern is that it was kind of the opposite of the concern that you raised about memory. It seemed like you wanted to kind of hang on to that causal antecedency as the right causal relation, so that, you know, something like scene perception where you're saccading around isn't mostly memory, it's actually perception. But it seems like if the format of visual short-term memory turns out to be perceptual, whatever that means, so maybe it's iconic or something like that, then your criterion on seeing is going to include things that we straightforwardly, I think, would want to call memory. So even if like visual short-term memory representations are perceptual, even if they meet all those criteria that you've laid out, it still seems wrong to say that we see them rather than we remember them.
Thanks, that's really interesting. Can I ask you to say a bit more about why you think the iconicity of the format is going to get that result?
Sorry, I muted myself. I wasn't expecting that. So the thought is that like your criterion on seeing is that you're actively maintaining some visual representation that's causally related in the right way. So with short-term memory, you're going to have the active maintenance. You're going to have the causal relation if it is causal antecedency. And then it seems like if it's representing in the same format, in the same way that vision is representing, then it makes sense to me at least to call it a visual representation or a perceptual representation.
I see. So I think maybe something that didn't come out much in what I was saying today is that I do want to include some kind of requirement that that representation be present in your experience in a particular way. And so I wonder, I'm sorry, I know it's hard to have a kind of back and forth with the muting thing, but I don't know if you have a particular instance in mind that you're thinking you definitely want to be like, that is totally in memory, that is definitely not in perception. I mean, if it's featuring in your experience of the scene in the relevant way, then I think I'd be willing to bite some bullets in terms of allowing that there would be representations of this kind that are genuinely perceptual. Yeah, did you have a particular example in mind?
Yeah, I mean, I was just thinking you're really kind of typical working memory, visual working memory thing where something shows up and then it goes away and it doesn't come back. And I guess independent to be concerned about including your conscious experience in perception, because I think there's unconscious perception, but that's maybe not.
Right. Yeah, no, good. Okay, yeah, that's helpful. And right, and you're going to have cases where something is occluded and then it doesn't come back again. It just stays there behind the occluder. And then we want to know, well, at what point do I stop seeing this? And yeah, I'm happy to say that for some period of time after it's initially occluded, you continue to see it, even though it's stuck there behind the occluder. And that there's going to be some gray area. It's just going to be a vague cutoff. At some point, it ceases to be a representation that is distinctively visual and it just ends up being in memory. So I think of it in terms of you need to have I think of it as kind of like a sort of luggage carousel where you want it to kind of come back and be rebooted at some point by a kind of refresher relationship with the object that you're seeing.
Okay, yeah, that makes sense. Thank you.
Okay, great. So there's another question more addressed to EJ by Jesse Breedlove. So if you want to unmute yourself and ask it now.
Yeah, I actually meant this a little more addressed to Jesse, but it would be awesome if it was a
oh, sorry. Yeah.
a more open discussion. So I'm presenting a case study actually tomorrow about a woman who is retinally blind, but she was previously sighted. And she has these visual experiences of objects in her environment that are triggered either by proprioception or tactile interaction. So she can see her own hands, or if she picks up a glass, she can see that. And she reports that these visual experiences are very much so like vision. So they're spontaneous, they're voluntary, they're persistent, they're stable. So would you say that, so these visual experiences are very much so consistent with her environment. So would you say that she is seeing then?
Jesse, did you want to take that one, or am I?
I can do, but I also want to answer it in a way that ends up posing a question for Professor Sham. So do you want to go first?
Sure. I mean, so, well, I don't really have a view about what it takes to see, although I found Jesse's talk very interesting, and I think I'm inclined to agree with a lot of what Jesse said. But I think that the issue of whether you can have visual phenomenology through a non-visual modality is like super interesting and kind of cuts to the heart of a lot of what I'm worried about. Sort of the next step of this kind of visual tactile shape perception project is to sort of characterize those aspects of spatial phenomenology that are really kind of vision specific versus those aspects of spatial phenomenology that are kind of accessible through multiple modalities. And so these sorts of subjects like I'm really interested to see that. So if you could send me that would be wonderful.
Oh yeah, and I have a poster tomorrow too if you want to stop by.
Right.
Yeah, I what EJ was saying there about, I mean, that's a fascinating case, and I think it's one that I don't know what to say about, and I actually think it's appropriate that I don't know what to say about it, because it seems like so unusual a case that it would be sort of surprising if we had a criterion for what it takes to see something that delivered a kind of determinate result in cases like this. But one of the things that it makes me wonder, that I think is generally very puzzling and that came up a bit in EJ's talk, is just why do we have different sensory modalities, or why are they reflected in our experience? So I was particularly interested in some of what Professor Shams was saying about kind of giving up on a model in which you have these kind of really separate, corralled modalities in favor of one where you have just thoroughgoing intersensory kind of processing. But then that seems to make more pressing this problem of like, why then do we end up having distinct visual and haptic and tactile experiences rather than something that's more thoroughgoingly blended in such a way that it seems like you can then have this as a question, which is like, does this count as an instance of visual experience or not?
This is wonderful. I wonder if this is a good time for us to start shifting slowly from maybe questions addressed particularly to the speakers and commentators, and perhaps use the remaining minutes that we have to start reflecting, maybe based on their talks, and slowly moving away from them to the fields and how these interact, how, I mean, everyone who's in these Zoom room at the moment have some interest either from philosophy or psychology or both, to make these two disciplines talk more to each other, to understand each other. And perhaps everyone has experienced as Kevin was saying at the beginning, that this doesn't happen automatically. This takes some effort. This takes some willingness from participants in these interdisciplinary discussions to learn from each other and learn the other's literatures and the other's language, even to have productive discussions, which is something that myself, I have experienced it by moving back and forth between the fields. And I know that this takes time, and I really, really appreciate people being here thinking together how these can work in a productive way. So if people have questions about these aspects in particular, I'll please send them to me in the chat, and I'll make sure that you can ask them. So perhaps in this spirit, Brian Scholl has a question that I think that can help us think about philosophers and and psychologists in a broader sense. So on one hand, we're all here vision scientists and philosophers of perception, but there are other areas of philosophy that could be helpful for vision science as well. And I think that his question could help us understand these, or can help us think about this issue in an interesting way. So Brian, if you want to ask your question.
Hey, thanks. This is a question for everyone, I think, for you, for Chaz, for Ned and Jesse, and all of the great philosophers I see here. It might also be about the sort of mission of phiVis. Is that how we pronounce? Is that how we pronounce this? There's something I've never understood about the interaction between our fields, and I'd like to understand it. The work that we heard from today falls under the category, I guess, of philosophy of mind or philosophy of perception or something like this. And there's this huge, rich body of interaction between these fields, led in no small part, I think, by people like Ned, who have been like, I tell people all the time that I've learned about preprints in my own specialized areas that I didn't even know about from talking to Ned sometimes. But there's another area of philosophy that doesn't seem to interact with our field that much anymore. I mean, even more broadly, there's all this work on philosophy and psychology when it comes to morality, when it comes to epistemology, but the field of metaphysics seems to me, although many of the sort of focused questions are different, our colleagues in metaphysics are studying the nature of objects, of events, of time, of causality. And those are exactly the same topics that so many colleagues here at VSS are studying. I have been struck over and over again by the fact that it's like many of the same ideas, the same manipulations. This was brought home for me once by a figure in a history of science paper looking at fission examples from the 18th century. And literally one of the figures in that paper was like the same figure we had in an experimental report. And so I just wonder if people in general see helpful synergy, not only with philosophy of mind, but also with this work in metaphysics. And if so, why isn't there more synergy between those fields? And is there something that Kevin and Chaz can do about that? Addressing questions to everyone at the same time, I realize you.
Yeah, anyone in the panel who wants to take
and silence, but maybe just anyone with a thought could answer.
Look, yeah. I would have a very negative thing to say about metaphysics, but I see Jeremy Goodman is here. He's a metaphysician. Let him answer.
Ooh, on the spotlight. Jeremy, if you want to say something, yeah, okay.
No, I agree with Brian. I think, why hasn't there been more as a sociological question? I don't know, it probably has to do with the contingencies of who talks to who. I think especially for these questions about like, I don't know, a lot of stuff Brian has worked a lot on, but we were also talking about today, how to track objects behind occluders and under various transformations. I do think I'm trying to remember who talks. I don't know. Sometimes people talk about like the kinds of things which lead to surprise versus not surprise in tracking studies as suggesting there's a special kind of category of thing, the Spelke object, for example, as people sometimes say, which is like, a thing which can change the kind of thing that it is, but always has continuous trajectories or something like that. I think that's an area where, for example, metaphysicians could say, no, that can't be what's going on, because that says, that implies that there are kinds of, lemons that can turn into limes or whatever it is. So I do think, that's just something I've thought a bit about and was maybe going to write a paper about at one point and I didn't. But those sorts of things about the metaphysics of objects and how that relates to tracking, I think, are helpful. And maybe more generally, like there's a kind of deference to the world as we experience it. It's like, oh, there's, the category of thing that we see versus the way it really is. And to a certain kind of metaphysician, that can feel like something like kind of relativism, where it's like, oh, I don't want to, say that another culture is wrong. So they must be just like changing the subject matter, or, the subject matter itself only has truth or falsity relative to a certain culture or way of thinking about it. And I don't think we should think that there's the world as it exists relative to our perceptual systems, and there's the world as it really is. And I think there's a way, just focusing on perception, you can encourage to think about the thing on its own perceptual terms, and it could be more grounded, or at least shaken up a little bit by trying to have impose that kind of discipline from metaphysics in that particular way. But that's just I don't know, I'm talking too much, and that's a corner of it that I've thought about. I don't think it's like the whole of ways in which there can be crosstalk either. I think that's just a small
Well, I think we all can agree that you should get to work and write that paper, Jeremy.
That's great. Thanks, Jeremy. Sorry you were put on the spot, but we appreciate the answer. Chaz has something to say.
Yeah, I was just going to chime in to maybe wonder if there's like an instructive counterexample to the lack of interaction between metaphysics and perception research, which is the metaphysics of color. In giving this counterexample, I'm like talking about two things that I don't know that much about. So, but I felt a little emboldened by a DM from Jonathan Cohen that suggested that's onto something. So the metaphysics of color, asks about, asks the question what colors are, do they exist in the world, are they objective, and really does frequently pay attention to vision science, and vision scientists seem to think about the metaphysics of color often enough. Maybe this isn't such a great counterexample because color just feels closer to the mind and brain sciences than some other topics in metaphysics. But I wonder if it's an example that either is like the exception that proves the rule, like the kind of metaphysical question it has to be is one that's already so nearby to us over here in vision science, or if it's like a helpful bridge to the other side. Like maybe there are some lessons to extract from that kind of interaction that could lead us to some other kinds of interaction. Now, like this is where like what I have to say ends, because I just feel like there are too many people here who know more than me about both of those topics. But I wondered, not to put anyone on the spot, but I wondered if any of the color experts here, Jonathan, if you wanted to unmute yourself, I could give you the power to do that. Or Anya Hurlbert, if you wanted to. I wonder if there's anything to think about there as like a kind of shoehorn into ways to promote that kind of interaction.
Well, I mean, I guess I can just briefly say, yeah, I thought this example was really striking and inspiring, because I feel like every one of the three areas of the metaphysics, the philosophy of perception, and the psychology of perception are fully in conversation with the other two. I mean, we heard today examples where Anya Hurlbert was drawing on the philosophical literature, and specifically with respect to the metaphysical literature. A lot of the arguments about the in the metaphysics of color are directly drawing on first order results in vision science. So I think it's a really rich set of interactions. How widely does it expand other topics in metaphysics? Well, I think there are interesting limits. So many of the issues famously connect with issues about the metaphysics of value properties and so on, where you probably aren't going to get a lot of input from the vision science side. But I think that's a good set of discussions to have also.
Maybe we could just say that there's a lot of topics. I totally accept that color example. There's a lot of topics like rules for continuity and persistence that have been discussed so fabulously in metaphysics, that have at least less commonly made contact. And time perception, although I see Ian Phillips here who's done some of that. Like there's just so many topics where I feel like there's a gap that this initiative could fill, even beyond strengthening what's already there.
Yeah, I agree. This is great. To a very large extent, the three philosophers that we invited to give the talk, I think they think of themselves as philosophers of perception, but I think all of them, they also do other types of philosophy or think about other problems outside of the realm of perception. And they still interact with vision scientists or other type of scientists in their work in ways that are still incredibly fruitful and inspiring. And I think maybe that's a good wedge to maybe even broaden more our reflections today and say, how does one do these, right? Of course, this event is one way of doing it, but there are efforts around different labs or different philosophy departments to achieve these. Some involve joint appointments. Some involve having philosophers attend lab meetings or hiring philosophers. There are other efforts at like the journal level, perhaps allowing or inviting philosophers to participate in to publish in scientific journals, and the other way around too. Scientists like sometimes are invited to participate in philosophical discussions or publishing philosophical journals. And I'm wondering if people in the audience have ideas or suggestions of how to keep strengthening these bridges that, again, they do take time to build. So if anyone has that, comments on that, that will be great. I see in the chat that Li Xiaoping has a question along these lines, perhaps, or something else. So if you can unmute yourself and ask it, that would be great.
Oh, thank you. I have been enjoying this very much, and particularly notice the philosophers here are very much like natural scientists, which is a really great joy to interact with. And I just wanted to add on to other people saying that perhaps we can look at these interactions between vision and touch and all these kind of things. They are just all senses. It's like our photoreceptors. We have 1 million or 10 million. You can have 2 million more. There can be even more. So therefore, all these touch senses are just more senses. Yeah, the senses could be the hearing hair cells or the smelling cell. They're just senses, and therefore you kind of get a. And so in this way, I'm actually agreeing with Shyam's idea in the sense that we are sensing. Seeing is just sensing. You can say, I see with my ear and I see with my nose, and we can just put it as sensing. So we even use it language-wise. They say, oh, I see what you mean. And these, they're just all sensing. And so therefore you can have higher acuity senses when you have more receptors, whether they are all visual or visual plus touch. Could that be a way of kind of uniting it across senses? Maybe that's not quite the...
No, that's great. I don't know if someone from the panel wants to address that. That's great. Or we can also move to some other questions.
Can I just throw in a comment that I think that the notion of embedding philosophy and philosophers into the study of perception and psychology and indeed neuroscience is a brilliant one, and we should really advocate for it. I think, if we put that into education as well, that studying perception should involve studying the philosophy of perception. That would, start us off on the right tack. And I think not least because philosophy really, it just sharpens the thinking, because it really makes you think about the terms you're using and what the reference actually are. And I think in science, we too often sort of blithely throw around terms because they've been used in the literature, and we just pick them up and reuse them without really giving deep thought to what they actually mean. And I think then that sometimes sets, empirical tests off in the wrong direction. So I think there's just huge value in embedding philosophy into psychology, study of perception, and neuroscience. Don't know how to do it, but
slowly and carefully. And actually, Karen had a comment on that, on how to, build interdisciplinary collaboration. So I don't know, Karen, if you want to go ahead. Yeah.
Yeah, so having sparked a collaboration with Kevin Landy a few years ago, I can say, one way that happens is going to talks outside your discipline. So Kevin came up to me after a talk once, and he was like, I think your work relates to these issues in philosophy. I said, tell me more. And we sat and talked for a long time. I had to explain lots of my terminology. He's still explaining to me a lot of his terminology. But about 2 years later, after having lots of these conversations, we're starting to learn each other's languages and be able to poster together here at VSS. Which sparked from him just being at a talk. And so I think for all of us to approach people who are interested in the same questions, but from very different perspectives, is a really productive start. And then being really vulnerable and willing to say, I don't know any of the things you're saying, just please explain, and allowing each other to give the time and space to explain and to ask questions, I think can lead to really productive collaborations. And I think these collaborations wouldn't exist without the partnership across fields. And so I think this is a great opportunity to start these conversations, but I encourage us to go to talks outside of our areas so that we are posters so that we can spark these new collaborations.
Yeah, I couldn't agree more. And Jiqia Chen, you have a comment on this too, I think.
As a junior researcher, I want to offer my perspective about more general, like interdisciplinary collaboration, not just about philosophy. I find it difficult to pursue that direction, not because lack of interest or lack of like possible question to pursue, but actually because that if I do that, that will actually possibly negatively impact my career. Because, well, if I publish somewhere that is not a typical journal in psychology, is that going to be valued the same way? I don't think so. I actually have a computer science like random conference paper, and like no one had ever talked to me about that paper. No one had ever even noticed that it's on my CV. And I think this really like have practical impact on my where I have this thoughts about question, and I really start to think that, how am I going to publish this? And then how is it going to, like, I'm going to spend a lot of time on this collaboration with medical school? Is it going to become a medical paper that no one's will really understand or care about, like in my career? So that's like a thought.
Yeah, no, thanks for sharing. I think that's, I mean, this is something I myself have worried a lot about and try to navigate it as to some extent, as a minefield too, because it's people appreciate interdisciplinary work, but it's in hiring practices, for example, that sometimes doesn't get reflected as clearly. Brandon Ashby on the chat raised basically exactly the same question for, from the philosopher's perspective. So yeah, this is something to consider, I think, especially, for maybe for the more senior people in the field who might have more power of deciding these things. It's not enough, I don't think, to be interested in interdisciplinary work. It really has to get supported in the right way. So, and I think, Karen, you wanted to say something else.
I just wanted to briefly say that there are ways to do these collaborations where it can push both fields forward. And so having that conversation very early on, being this is the kind of piece of this project that would go in a psychology journal. This is the piece that would go in a philosophy journal, in ways that can be mutually beneficial. So I think there are ways to carve out different parts of projects so that all of the people involved can advance their careers. And if that's not possible, it might not be the right collaboration.
Yeah, so sorry, I muted myself then, but I have very related thought to Karen. Like, I think it's very possible to actually have a journal that both will recognize. Like, I think in the name, as long as like it says like philosophy and psychology, like people would like at least take a look at what that paper is about, right? Like, so even this simple superficial solution might be helpful to at least get some attention to that little line on your CV.
So this has been wonderful. Unfortunately, we don't have time to take more questions. I'm so sorry I couldn't call all of you wonderful questions. I really enjoyed these, and I really appreciate the time that everyone took for being here. And I think Chaz and Kevin want to have a last word. So please go ahead, and thanks, everyone.
Are you able to hear me?
Yes.
Great. I just want to thank everybody so much for what has been, I thought, an amazing event, just sitting back and watching it happen. So it was really, really grateful to have the speakers that we had, to have the comments that we had. The questions that we had were excellent, and to see this discussion at the end, which is really, Chaz and I had prepared some questions at the end that we might sort of get discussion going. They sort of naturally landed there. I mean, there's, these natural questions of, we're in these different fields, we have different vocabularies, we have overlapping questions and interests. So, what value can we find in having those kinds of conversations? both at an intellectual level, but also just at a professional level. How can we add value and recognition to those kinds of exchanges, which are hard to get going institutionally and sometimes hard to get going intellectually? So I want to thank everybody for sticking around for just a really excellent event with way more people than I expected would be interested in this subject. I mean, it really was staggering just to see how many people registered, how many showed up, and how many people have stuck around even well past the official closing time. So thank you all so much.
Oh, we all want to thank you and Chaz for this wonderful thing that you've put together.
I was just going to add that we'd also like to thank our institutions. So we had some support from York and Johns Hopkins, and just in general, our two institutions have just really supported us in pursuing this kind of interdisciplinary stuff, which has been great. And just hopefully this is also encouraging for the future. Kevin mentioned the turnout. When you fill out a form to request a satellite event at VSS, you have to say how many people you expect. And I think we wrote down 25 to 50, but instead between YouTube and here, we had about 300. So that was pretty awesome and hopefully bodes well for future events. So stay tuned for more of them.
And we do hope there will be future occasions to have this sort of thing.
All right, good afternoon, good evening, good night to everyone, wherever you are. See you next time.